In a frequency distribution, data are displayed so that their variety and their frequency occurrence are apparent. So the frequency occurrence can be represented by f. That means the number of times a score is repeated in a frequency distribution. Every measure is independently represented in either an order or disorder array. If you can see here, this set of data can be transformed into a frequency distribution. Before this, we learned about frequency distribution. So for group frequency distribution, we group the data into a class interval. So the guideline for developing a group frequency distribution, first, the group must have equal range and a particular score or observation can fit into just one group. For example, we have this set of data. So, to transform it into a group frequency distribution table, we must create class intervals. And the class interval must have equal range. And also, each score must fit only one group. Before this, we talk about frequency. Frequency refers to how many times a particular data occur. Next, we want to know about relative frequency and cumulative relative frequency. Relative frequency refers to the fraction of time a data occur. Meanwhile, the cumulative relative frequency refers to the total of the data from the particular interval with those from the previous intervals. For example, we have this dataset. Before this, we already transformed it into a group frequency distribution table. Now, we want to calculate the relative frequency and cumulative relative frequency. So, for relative frequency, for example, the last class interval 20 to 24. The frequency of data for this class interval is 1. So, to calculate the relative frequency, we have to divide 1 by the total number of the data in this data set, that is 12. So, the relative frequency for the last class interval is 0.083. However, for cumulative relative frequency, we have to sum up the relative frequency for previous class interval and the current class interval. So, for the last class interval, that is 20 to 24, the cumulative relative frequency is equal to 1. For a frequency distribution table, we can determine the actual mean. However, for a group frequency distribution table, we only have class interval. So, we cannot determine the actual mean because we cannot determine exactly the data were. So, we only can calculate the approximate mean. So, these are the steps to calculate the approximate mean value. For example, we have this data set. So, we can calculate the actual mean. The actual mean for this data set is 9.75. However, for a group distribution table like this, we cannot determine the actual mean. So, we can only determine the approximate mean value. The first step, we have to determine the midpoint for each class interval like this. After that, we multiply the midpoint value by the number of scores in the interval. So, the approximate mean for previous group distribution table is 9.917. Next, we take a look about apparent limit and actual limit. Apparent limit of a class interval refers to highest and lowest integer in each class interval. For example, class interval for 0 to 4. So the lower apparent limit for the class interval is 0 and the higher apparent limit for the class interval is 4. However, it is different for actual limit. So this is how we calculate the lower actual limit and higher actual limit for each class interval.